Ladies and gentlemen, hello and welcome back to Dubious Engineering. We have a very special guest star on the show today, David Watts. Absolutely fantastic. He's absolutely brilliant at digital electronics. Anyway, David's going to show us around his lab first, so we get a bit of an idea of, what makes him tick. And then we're going to get a little bit of time to have a chat with him afterwards.
So this is the workshop. Really, it's the second bedroom. But it's been basically my workshop since I moved here. Like most of you, I don't really have an efficient space. I'm just using it as I can. So I've got like a couple of these IKEA desks. This one's is one of these ones with a handle that means that I can work standing up. I never work standing up. Literally thought it was going to be cool, and then I just did it like twice. So I've got a PC here. This is where I do PCB design. I've got like a mic on an arm here for when I'm doing recording. And as part of a project, you can see part of it here, I guess. I've got my Commodore C64 here, not only to do interfacing with a computer or with in my case, an ESP32, but also I was simulating the tape player there. I've got a 3D printer, not plugged in. This is a FlashForge Finder, really good bit of kit. I know it looks like I take no care of this. Let's brighten that up. But I do actually take care of this. The inner workings are fine, it's just a mess. I'm not really bothered about it being a mess. This is actually a secret project, this one here, working, not secret, but the development so far is secret. You'll see loads of boxes like this. Everything's going to fall, but basically projects get put in boxes so they don't get lost or mixed up. In fact, there's a whole cupboard full of stuff in here. So each one of these sort of trays has various components in it, and inside each one of these is lots of different components that I might use in a project. Honestly, I don't really use them all. So that's why I've got loads of them. I've got 3D printing filament at the back there, and then a double height sort of drawer thing for stuff that's a bit bulky and I don't really use. So it's not the only thing that gets sort of left by the wayside. Like if you make projects quite often, you'll know that things like, I've decided to make a robot today, doesn't really always end up working out. I've also got this guy here. It looks better when you can't see the bulb illuminating it. This is a Commodore PET 2001, and I've had this for quite some time. The idea was that I would fix it. It's a really cool design, actually. If I can just rest the camera there. It opens up like a car bonnet. There we go. So you can work on the inside with it all together. Now, it's working, but it's not a nice thing to use, honestly. This chiclet keyboard, let's put the lid back down. This chiclet keyboard is kind of horrible to type on. The keys are mushy, and I've attempted to clean the keyboard, so I've taken it all apart and sort of cleaned off the carbon pads and stuff and rubbed a bit of pencil on there to help it work better, but it's still a bit mushy. I've also got this little broken ZX Spectrum. Now, I'd hope to get this thing working again, but I need to get myself a keyboard that goes, a new keyboard membrane that goes in here, but not found one yet. Not one that's affordable enough. On the top here, I've got a little rogues gallery of projects. This is an old Zenit TTL camera, but it's actually been converted to a pinhole camera, which is fun to play with. Here's the crap clock. Are you going to focus? There we go. Counting away. Should be roughly accurate. This one is from Elector Labs, and it's these sort of VFD displays. But if you notice, just in there, I've bodged in, just down here, bodged in an ESP8266 to automatically update the time as the old crap clock. And one of these, a Don't Panic badge. Now that's interestingly what's illuminating the Zenit. is one of the don't panic badges with the LEDs on. And that just sort of sits behind there and illuminates it. So over here is mostly where I do any of the practical work. So you'll see that I've got a little 10 mAh power supply. This thing's great. Let's see what it goes up to. 31 volts. Actually says 0 to 30 at 3 amps. Let's bring this back down so that I don't accidentally fry my stuff at some point. I've got a 10 mAh soldering station. This thing I've had for years now. It's been brilliant. And I just recently got this 858D hot air soldering station. Not the best thing in the world, but it's perfectly serviceable. It can do pretty much anything that you'd want to do in surface mount soldering. I don't have a heated plate or anything to preheat my stuff. I'm just going to use that for a while and see how I go. I have an oscilloscope. Actually, I've got several, but this is the one that I use because it's a nice digital LCD one. It's the SDS1202XE from Siglent. It was pretty cheap. I got it when it was like an X-display model, so it's about 180 quid. So it's quite nice. So this desk is generally quite messy because this is where I'm working most of the time. So currently we've got the millisecond clock in breadboard form. So it's taken quite a few breadboards here, as you can see, but this is a CMOS millisecond clock running all these little displays. Other things, like there's so many of these that end up in my little workshop. Lots of little boxes where I put components and just never really worry about them. Like this thing, like that. Never going to use those. But I also use these to put projects in that I want to revisit. So this was going to be a badge that reacted to your voice. Kind of lost interest, but I may come back to it. This thing is actually for that there, which is a clock that I had intended on finishing and never did. And I did that with the Unexpected Maker, but never quite finished it. Again, similarly, stuff like this, little thermal printer. Anyway, and my tools, I guess. Oh look, there's more stuff under here. Not that you can see all of that, but yeah, more stuff under there basically. Projects that are ongoing or will never be finished or may be finished, old laptops too. So these are my tools basically. So I've got a few multimeters in here. This is a big magnifying glass. And I recently bought this bag because I like the fact I can just pick it up and move it around my, I'm going to call it an office. But it's got loads of different pockets so I can put all my different things in there. Like Kevin the Stripper, which is something one of my viewers sent me a while back. These are some cool wire strippers. His name was Kevin. So yeah, oh, and these big lights. These are what I use to illuminate the desk when I'm filming something. I've got a window here so I get a lot of direct light, and if I need to film it, then I want there to be some nice light. Dotted around my house actually, I've got quite a few vintage bits of kit. So this is something that I'm using to hold the door open, and it's an ohm meter by Ductor. It's a big old thing. So these are the other scopes that I have. One's a Tektronix 2205. One of the channels doesn't work on there actually. And the other one is a Gould DSO 400, I think. Yeah, there it is, DSO 400. Both of these, in fact, this one works perfectly. This is fine, but it's just a bit old. So I prefer the new Siglent. And these are a couple of the other things that are sort of vintage kit that that I use occasionally. So this one's a resistance box, and this one is a decade condenser. So this one allows you to, this one allows you to sort of dial in a resistance. You can also use it to keep your pin number. I don't. And this one also allows you to dial in a capacitance. So with these dials, this one's super flaky. It's kind of a break before make connection. So if you're doing a circuit and you switch it it breaks the connection first, so it's a bit weird. But these are lovely. Look, it's like made in some like dovetailed joints and stuff. And this one's just a big old metal box. It's really meant to be used flat, but they double up as sort of displayable items in my sort of vintagey kind of looking corner here in the living room. So I also maintain a sort of stock of parts of things that I might use. So I have lots of ICs. These are mostly CMOS ICs that I use. So I have a lot of them. There are some operational amplifiers in here, various other bits. Those are 4017s, which are decade counters. But I keep a sort of stock of different microcontrollers in here too. Now, these all sort of come from in here. So this whole sort of shelving unit here has a stock of parts, similarly in those little organizers and some of those boxes. You'll see there's quite a few bits in here, and one here called Strange Materials. So this is full of weird and wonderful things that either I haven't used or I just haven't gotten around to yet. Like this stuff. This is like light pipe stuff I've never used. So yeah, there's lots of different microcontrollers. We've got, that's an Arduino Uno clone. There's a Raspberry Pi, another one. Oh, my favorite Raspberry Pi, which is the Raspberry Pi Model A. There'll be some ESP8266 things in here. Oh, there's a little oh, that's useful. I remember that. Little display. Turns out there's a prototype in here. Next-gen board. Oh my word, look at this thing. This has literally never been opened. So this is a chip computer. This was a Kickstarter from years ago. Never ever used it. Oh, and there's a blast from the past. That is not going to focus, but that is the original crack clock board that I designed. So it's pretty tightly populated, that one. What's this one? Oh wow, this is the DigiX from DigiStump. This was one of the first Wi-Fi enabled boards. Oops. Anyway, I think that's it for the tour around my very small little lab. So I hope you enjoyed it.
Ladies and gentlemen, welcome back to Dubious Engineering. Today, I have a special guest star on the show that I'm quite excited to share with you. We have Mr. David Watts from the YouTube channel, David Watts.
Hello, less the star, just a guest, that's all.
Oh, absolutely no. In my eyes, my friend, you're a star. You have a lovely, relaxing, educational and entertaining electronics design channel. And primarily, you tend to sort of like work through digital electronics. You're not sort of you're less of an analog guy. I would consider myself slightly more analog, and you're a little bit more digital. At least your more recent projects have been anyway. In fact, talking of projects, one of the projects that you did some time ago was the eInk paper display with an Arduino, I think it was.
Yeah, so Waveshare is the company that makes these specific displays. And it was a while back. They'd just come out, just became affordable modules that people could buy. And I just so happened to tap into that at the right time. So it was a fairly popular video. In fact, I've got the very model just over here. Whoops. And I turned it into a social media counter. So that's it. I'll move my head out of the way so it focuses. I don't use it anymore because most of the social media counters have sort of broken over time. The YouTube one has become something that averages out your count. But this was a really fun project to build. And I was doing it at a time when the ESP8266 was still fairly new on the scene. And that's not quite true. What I mean there is that it's still fairly new to the Arduino environment. So it had become really very quickly accessible, but it was still early days for this. And this involves some 3D printing as well. So I created a case which is really weird and a bit 70s looking, but I love it.
I love it as well, mate. Yeah.
And it's so it's designed to sort of sit like that. And so this is dubious engineering right here. In the bottom there is just some blue tack, which is weighing the thing down. Because obviously it's fairly top heavy. All of the components sit here, and the screen is there. You can see how old this project is now, actually, because you can see where the glue has yellowed over time around the outside. But in here, if I can remove this like year-old bit of blue tack.
That's super. So whilst you're just removing that, the key thing about the eInk display is that it uses very little power, and actually you can basically blip it with a set of signals that makes it display something, and then walk away from it and forget about it and turn it off, and it'll still sit there displaying what you blipped it with when it was you blipped it with it.
Exactly. So this one uses this little module here. What was it called? I cannot remember for the life of me, but these were one of the early boards. I'll move my head out of the way. One of the sort of early boards that you could get with the ESP8266, and this one did not have a USB comms chip on it, so you had to have another board for that and a sort of a shield. But it's all pretty janky, as you can see. Wires going up on the inside to go to the display. Now, if I can focus this is when social media counters started to break, and also I sort of became less interested once I'd completed the project, once I'd learned everything.
Yeah.
No longer really needed it.
Time to move on.
If you can see on the display, you'll be able to see when it last updated.
Oh, wow. 2000, so 1303, that's 13th of March, 2019. Yeah, yeah.
Yes, that's been on the display for over a year. It hasn't been powered up. So that's like the great thing about the ePaper displays. You can put something on there, and it will be there for a very long time. I don't know how long, but let's say forever. It won't be forever, but over a year that's been on there. So you can, I think places in China and Japan use these as price markers in shops and things, so they can update them with a phone. In fact, Wayshare have released a new display, which I'm hoping to get, which is NFC powered. So you can hold your phone over it. The NFC signal charges a capacitor in there, boots up the microcontroller, transfers the data, refreshes the display, and then you walk away. So there are no wires involved.
Brilliant.
And they're really cool. So they've got ones by up to 6 inches, I think. So really big.
Wow.
And the idea is that you could, for me at least, I could copy a schematic to the thing using my phone. I mean, really, I could just use my phone to look at the schematic. But then it could sit in a box with a circuit that you're working on. Come back to it, you've got the schematic in there. I don't like having a printer, so that's one of the reasons I like these things. So I can't print anything out here. I have to look it up all the time. But yeah, this project, I learned a lot about low power devices. So this thing goes into a low power mode and draws microamps, especially since this one doesn't have a USB comms chip on there. The only thing drawing current is the ESP8266. And I think it's something like 10 microamps, but don't quote me on that. Although this is a video, so I'm directly quoting myself. But so yeah, it was great that it went down to low power. The only thing I didn't really do is give it a way to be low power. So it's running from a USB cable, which means anything that's going into it is going to be drawing a lot more than 10 microamps. So if it were battery powered, it would have worked out well. But yeah, this is it was a popular video, and I was really surprised that so many people were interested in it. It took me a while to learn how to use it, but now Adafruit and all sorts of other companies have sort of come out with libraries, not companies, organizations have come out with libraries. This was based off the GXD, is it, library maybe, which is one of the earlier ones that works on like the 1306 displays as well, which are little LCD things. So it's great. Really loved working on this. And this was at a time when I had 21,125 subscribers, apparently. So,
and now you've got just shy of 24,000.
Yeah, just shy of 24,000.
So that was the eInk display, which I found really very useful. So thank you for that video. The other one that you came up with, which was quite good fun, was the crap clock.
Here we go. I'm going to be haunted by crap for my entire career on YouTube, I think. So I've done a few crap things. So there was Oh, it's probably around. I could find it. The crap cricket. I don't know what that is. That is just a little noisotron type thing. A noyatron, I think they're called. You know, where it makes a noise every 15 minutes. Can you find it? Super low power, runs off a CR2032. So I'd done that, but my first one was the crap badge, and I must have one of those somewhere. Yeah, so that's the crap badge. I can't tell if it's in focus because the video is too small for me.
Yeah, back up. Yeah.
The crap badge just was an award type badge, so it looks like a little ribbon you'd get for winning something, but it said crap on it instead. And this was my sort of first foray into CMOS type design, and the same with the crap clock, the binary crap clock. Actually, I'm not sure which one you mean because there are two crap clocks. So this one's the binary crap clock.
Yeah, just back up a little bit from the camera with the yeah, about there. That's perfect. Yeah.
Okay. So this is the BCD crap clock. That's binary coded decimal. So this isn't an actual binary clock. So you don't read the numbers in the way that you would read binary. They go up and down for each digit. And that was like a really fun thing to do. And I made a kit and sold it on Tindy. And I think I sold about 35 of these.
Wow.
75 waiting for these. But they were going to have to wait for a long time because I'm not making any more. To put together this kit, not only was it expensive, but time consuming with all the components. So each one of these runs off each column is run from a CD4510, which is a decade counter with a BCD or binary coded decimal output. And so it runs along a line. So you have carry out signals coming from each one of these things.
Yeah, and they just sort of drip feed into each other and tick over.
That's right. But with a clock, you have to add some extra logic in there. So I don't know if you can hear the neighbours doing some work. So you can't have all the numbers count up to 9 in a clock. So you have to have some kind of logic there to say, well, this is the minutes. And so when it gets to 59, I need the 1 hour to clock over. So you have to have logic that connects those two bits together. And so really, that's just a bit of diode steering on here. So you'll see some diodes along here on the reset lines. I don't know if you can see the diodes along the reset lines there. And that's what that does, essentially. But that wasn't the only crap clock. So there is another one. Oh, it's connected up. In fact, I'm not going to be able to bring it over, am I? Maybe. Let's see what we can do.
Don't have to pull it all apart, drag it over. There you go. Got it.
I don't know if it is. Yeah, hang on. Let me just turn it on. So this whole section up here is sort of usually illuminated. Oh my. Sorry, Howard. This is like live TV type stuff, isn't it?
It's no problem. I can edit all of this.
Don't leave it in.
Is your fan on a rug because it makes too much noise when it's on the floor? Yeah,
it vibrates through the floor, so I can hear it downstairs.
Okay.
So this is that's something else. So this is the crap clock, the original crap clock. So I made this a long time ago. I probably learned more doing this clock. I don't know if you can see it. It's probably going funny because the refresh rate, because it's PWM driven.
No, it looks absolutely fine. It's just a very slight flicker, but it looks great, David. Yeah.
Okay. So the crap clock runs with a TLC 5940, which is how many outputs does that have? It's something like 12 or 14 or something like that, maybe 16 outputs, and so that's driving all of the columns. And then the rows are driven by a CD 4017, which is a decade counter. So essentially, it's pinging through, and then so each row is activated at one time. And then the TLC 5940 PWM LED driver runs each column. So we're just getting a scanning effect going up and down like that. And so over Over here, you've got some pink LEDs. Hopefully you can see them. They are counting every 3 seconds. I didn't have enough LEDs to do one a second, but every 3 seconds, one of those illuminates. And then we've just got the time there. There are some buttons, but I cannot remember what they do. Oh, it does have the date in there. So that says it's Tuesday. Is that right? Is it Tuesday?
Wednesday today.
Oh, okay. Well, it actually says Sunday, the 26th of the 2nd. So at some point, I didn't bother setting the date, but the time should be roughly right. Maybe. It's 25 degrees as well. So it's got a lot of functionality in that. It's also 3D printed in wood filament.
Nice.
It says crap clock across the top, a couple of buttons, and just like most of my projects, they never really get finished. You know, they never quite get across the finish line, and I finished learning all about it, and so it still comes apart. So it is a tiny PCB. It's about 120 millimeters by around, that looks to be about 45 or 50 or something, maybe less than that.
So a key thing for people to know here actually is that David designs these PCBs and effectively designs all of this completely himself. So you take us through the entire design experience, the generation of the PCB, laying out the PCB and doing all of the wiring schematics and the various different copper planes and all of that kind of good stuff. And then you actually take us through the build process as well. And this is done over normally a series of videos. It's not done in one hit because that video would be incredibly lengthy. But it is really educational, mate, and you always make it fun as well. You always do it with a smile on your face and have a few little quips in there that keep things going. And then you do live streams as well, don't you? Sometimes, which are always good fun to come and join in. So
those live streams. So the thing about my YouTube channel, I call it it's an electronics vlog, because calling it someone who does tutorials and things like that, that's not really me, because I'm probably making more mistakes than most of the audience are, really, and then showing off what I've achieved. So the live streams are absolutely unfiltered mess, basically, but it's a whole lot of fun. I like doing it, and I get to interact with people while I'm trying to design something. And you sort of miss out on a really key part of learning all of this stuff, and it's the boring bit. It's the research. So there's designing all of this stuff and taking it into like a bit of ECAD software or something.
Yeah.
But there's also reading a ton of data sheets.
The preliminary work, yeah, absolutely. And you do a lot of that offline, I think, don't you?
Yeah, mostly offline, because it takes a long time, and you're looking at so many different sources, and it's hard to distill what's real and what's not. In fact,
yeah.
I've got a video coming up soon about the dangers of doing research. So I did a project in 2013 with this thing. Let's see if I can show you this. So with this thing.
Oh my goodness, look at that.
A Commodore C64C. Now, I was using the user port to, the port's over there, I can't show you, to throw data into that Commodore 64 from a computer. And it was, at the time, it was tweeting, because the API was a bit more open. It didn't have OAuth 2 attached to it, or at least you didn't have to. So I could tweet from my Commodore 64. And so I did a video about that, interfacing the C64. And I picked up some books about it, some old Commodore manuals. And I thought, this is great. I know all about the Commodore 64. But one of the things about doing research on older stuff like that, or looking at older data sheets, is they don't have the context of today. So the video I did about this, there were so many unnecessary things I did. And one very key thing, which I'm going to do a video about, that, I mean, it was just silly. So really, I didn't need to do many of the things I did in that video. And some people mentioned it recently in a comment on that video, and I thought, crap, I need to update this. So I've realized that reading old information on the web isn't always ideal. Even if it was right for the hardware at the time, it's not right for the current hardware now. So things maybe run on different voltages these days. So I won't go into it any more than that, but that's one of the things that I found out. But yeah, reading data sheets. So like for this, it was reading about CMOS devices to the CD4017. For this one, it was reading about the CD4510 and how I can do diode steering, and the CD4060 to create a 1 hertz clock. And then the more recent one, which is the millisecond clocks, which is a bit of an evolution of me learning about CMOS devices. And that one has been quite the learning curve, honestly, because there are some things that I've run into which have surprised me. So CMOS devices are not quite like devices you get now. So you get 7.4 series logic, which is super fast. It's like TTL level logic. So CMOS devices run to a lower logic level, and TTL expects a higher logic level, that kind of thing. But they're also faster. So CMOS devices, older CMOS devices, run slower, sort of, so they can't react in the same way. It's all about that metal oxide thing. So CMOS stands for
complementary metal oxide semiconductor.
Metal oxide semiconductor. And the older ones were the metal was aluminium. And when these things were early, they didn't react very quickly to changes. So it meant that they couldn't run at high frequencies. And so I'm using a 4.096 megahertz crystal for this milliseconds clock, because I need a way to divide down to about 100 hertz signal. And it ain't easy. If you want something accurate, I could throw a 555 in there and get something similar, but it's going to be way out over or I could throw a microcontroller, but it's sort of against the idea of it. But so, yeah, the CMOS devices, you have to pick carefully, or they're not going to work well at 5 volts.
Yeah.
And they change. So if you throw 9 volts in, yeah, they might work. They're at the higher end of the spec. But at 5 volts, it's not even listed. Like it should only maximum is 3.5 megahertz.
So one thing then I guess I would like to tell people is we just had a quick preliminary chat before we got on to record ourselves doing this. I had assumed that you were by training an electronics design engineer, because you're very capable, and clearly you've learned an awful lot about this kind of technology. When we spoke, you told me that you were a videographer and photographer.
Yeah, so that is my background. I've been a videographer, photographer for about, I don't know, 10 years maybe, something like that. But previously to that, I was a web developer. And even before that, I just did a bit of web design, and that was it. So yeah, I don't have a background in electronics. I did a degree in, I did a higher national diploma, I don't think they do those anymore, in computing. And then I switched to a degree in media, which is kind of where I got my interest in photography and video. So yeah, that's my job. My full-time job is a videographer. It doesn't mean my videos on YouTube look any better, because I can't afford the kit I use at work. So the camera at work is like $6,000, and my one's like 500 quid that's at home. So I do my best with what I've got.
Yeah, well, you do a fantastic job. And actually, the effort that you put into making your produced videos is quite impressive, because I know how much time and effort it takes to create a video. And you can slam something together in a couple of minutes. But if you want to really put the background and all of the information in, and you need to chop things up and change things around and then shoot another bit and then go back and do a voiceover and then collect another, it's really quite an awful lot of effort to capture all of that, and then to sit down and do all of the processing, the post-processing afterwards, and get all of that edited up and sorted out. So fantastic. David, one last question. Surface mount technology, as I mentioned earlier, is something that I'm not great at it. So I saw you the other day soldering a surface mount chip to a PCB. Just talk us through that quickly. What kind of is the special equipment that you need to do that? How would I go about changing a surface mount chip on a PCB?
So I will say that you don't always need to use the specialist tools to do surface mount stuff. So I started doing surface mount stuff. All of these things, mostly, in fact, everything I showed you has included some kind of surface mount technology, and I used an iron for all of those. It takes a while, it takes some steady hands, but if if you can do it, then it just takes a bit of patience. And I've soldered all sorts of chips, but when we talked earlier, you talked about sort of QFN chips and those sort of smaller components. And so I've picked up a hot air station. This is one of those super cheap ones. It's called the 858D. It'll come under loads of different brands. I'm sure you can drop in a clip of the tour of the workshop at this point and show that. But it's such an easy technology to use. It's hot air. Very little goes wrong if you keep it on a low temperature. But you do have to use solder paste rather than normal solder. And so there are some complications there. You've got some choices, and that's where complications come in. So I've got some cheap solder that I bought online for about £3 delivered from China. It's not thermally stable, which means you need to keep it cool. I keep mine in the fridge. And then there's another complication. You have to take it out to get it to room temperature before you can use it, before you can squeeze it out of the needle at the end. So it's all fairly easy to get going with, but it all takes practice. Just like when you first learned to solder, I imagine you were like putting the solder on the iron and then to the component rather than feeding them on at both at the same time, that kind of thing. Understanding how the solder flows, and if you're heating it up too quickly, lots of those things I'm still learning to perfect, if ever I do perfect it. But there are lots of little techniques you can use, like preheating the board, so that you're not competing with that negative thermal mass that you're trying to fight against. But one of the big things I've learned is that too much solder paste is a real problem. And so I've stumbled across that. I've literally used my hot air station about 3 times. I feel like I've gotten quite used to it. And there's always ways to improve. And thankfully, there's this amazing community, as I'm sure you'll attest to, Howard, on YouTube, who are perfectly prepared to give help in the comments to anybody that needs it, or even if they think they're doing the right thing. I kind of sometimes think I'm doing the right thing, and someone in the comments will come along and point something out, and that's always great. So I've got my stations all sort of over there, and you'll get to see that. But you don't need like a microscope. You don't need some kind of fancy setup. You just need a heat source, in this case, a heat gun, and a little bit of patience.
Fantastic.
Tweezers are essential.
Tweezers, yes, very fine tweezers. Fantastic. Well,
Yeah.
I might have a little tinker with that at some point in the not too distant future. But for right now, I'm halfway through the finishing the build of an Amiga laptop. And actually, talking of Commodore Amiga, I can see behind you there is a Commodore PET.
Oh, this bad boy over here. Yeah, this is a Commodore PET 2001. The blue label edition. It's all fancy in that. So my work, I work for a university doing their video stuff, and it was in their engineering department, still being used for a bit of equipment. This was many, many years ago. Hang on, 2014 maybe earlier than that. And so that bit of equipment got retired, and so the specialist software that was written for this was running that equipment. So this was no longer needed. And so we wheeled it out for some kind of 50 years of computing event. And then it got given to me to fix because it didn't work. So it turned on and there were characters on the screen, but they were all the wrong characters. And the video memory was full of garbage. And that tends to mean that either the chips aren't plugged in properly, some capacitors have gone because it's an old machine. So I only had to replace one capacitor, and I reseated the chips, and now it works fine. I find it's kind of a scary machine to use. So old machines, they've got like that weird kind of hum to them. It makes you think you're going to get damaged.
The whopper. Would you like to play a game?
It's got this kind of I'm irradiating you right now feel.
The high-pitched whine of the EHT coils in the back of the monitor. Yeah.
There's a capacitor in there that's about the thickness of my arm as well. It's kind of power supply. So it doesn't really get turned on. It's sort of a museum piece, but I think it's beautiful. It used to be in that cupboard over there, but I think actually it deserves a place
Oh yeah,
on show. I brought him out.
It's an iconic shape, isn't it? But David, thank you ever so much for joining us today on Dubious Engineering. It's lovely to actually sit down and have a chat with you. Absolutely fantastic. So guys and girls, if you haven't seen David's channel already, please go over there. Please check out his channel. There's some really interesting and cool, innovative stuff that David does. Thanks ever so much, mate. Sorry, I didn't catch the last comment. Say again?
There's also a lot of rubbish on there. So.
Yeah, well, that happens with all of us, doesn't it? You know. Thanks ever so much, David. Take care. Cheers for now. Ladies and gents, thanks ever so much for watching. I hope it's been fun and interesting and slightly educational. David is superb. If you're not already subscribed to David's channel, please go ahead and subscribe to it. And perhaps subscribe to this one if this is your first time watching. This is Dubious Engineering. Thank you ever so much for watching. Please don't forget, give us a good old thumbs up. And we'll see you again in the next video. Take care.